Now let's go to the second problem. Find all the unknown currents, and I have given a clue that you should use KCL for that purpose. One thing you should keep in mind that node, whenever you see KCL, you have to apply KCL. That means that you have to consider a node to write KCL. Similar to the KVL, we have to assume a loop. Whenever you have to apply KCL, you have to consider a loop. Loop is a closed path, and node is a junction of two or more elements. So I can see that, okay, to find all the unknown currents, I have to know all the nodes. You can use the surface for a node, and also you can just pinpoint or highlight one particular node. For example, if this current is here coming in this direction, so it is this seems to be the junction of current source, this resistor and this resistor. So this is a node. In this particular case, this current source, this resistor, and this dependent current source are joining at these. This is the junction, so this is the second node. Similarly, these four elements are meeting to this point, so this is a node. This is a node. These three elements are meeting here, and this is also a node because current source, this resistor, and this dependent current source are meeting at this point. You can extend a node by a conductor like this, or you can also make a kite shape here. Directly you can connect here, and this terminal you can directly connect here to make a single node, but you can extend a node by a conductor like this one. So this will not change if even you highlight this particular, if you encircle a surface here, this would still be the same node. So whatever the voltage is here, the same voltage would be here and same voltage would be here. So this is a kind of a brute force method to find to apply all the KCL at node 1, 2, 3, 4 and 5. So I'll write KCL at each nodes. In this case I am using the simple version of KCL, that sum of the current entering the node is equal to sum of the currents leaving the node. So at node 1, the current this Ix is leaving and I3 is leaving, so I have added them on the left hand side, and this current 12 milliampere is entering the node, so I have written this on the right hand side. Similarly at node 2, this is entering and these two are leaving, so I have written 2Ix is equal to I2 plus 12 milli, which is here. Similarly at node 3, this is also entering the node, this is also entering the node, this is leaving the node, this is leaving the node. So I'll add them on one side, I2 plus Ix, which is on this one, and I have added a Y1 plus 4 milli, which is on the right hand side. So I'm end up with the third KCL. Now KCL at fourth node is 4 milli is entering, and I3 is also entering, and all the currents are entering the node, so they would be on the same side. So 2Ix plus 4 milli plus I3 is equal to 0. Now KCL at node 5, this is entering, this is leaving, and also 2Ix is leaving, so I can write this entering on one side and leaving on the other side. This would end up into I1 is equal to 4Ix. So these are the 5 equations, and in none of the equations there is a single unknown, so to speak. There are always two unknowns, so we cannot solve any of the equations directly. But the KCL at node 5, in this equation I can directly relate I1 with 4Ix. So there is no specific method how I will solve this one, but I have done this by observation that I1 is equal to 4Ix, and I'll find all the other 4 equations in which I1 is mentioned. I1 is mentioned in this one. I'll simply insert I1 is equal to 4Ix, and I'll insert 4Ix over here. You can see 4Ix is written here, the same I2 is here, plus 4Ix, sorry, plus Ix, which is shifted to the right hand side, becomes minus Ix, and I1 is equal to 4ix and plus 4 milli is here. If I solve this one, I'll get I2 is equal to 3ix plus 4 milli. So this I have named as equation 3a because I develop it from equation 3. So this is 3a. So if I substitute 3a in equation 2, so I know that I2 is written in terms of ix, and if I replace I2 with ix, so there's one equation and one unknown, and that is this equation. So after substituting that, which is written here, so I can find ix is equal to minus 16 milli. I can insert this ix over here because then this would be one unknown, so that is I2 would be found here quite easily. And similarly, all other unknowns now can be found because once I found I2, ix, I can insert the ix here, I can find I3, which is I3 is equal to 28, and all the other ix when substituted here can be found I1. So this problem would be solved.